In this video, we're looking again at a question from the describe questions. This is question 3, and we've got a model dinosaur that's pneumatically powered, and we're going to talk about how this circuit operates when a signal is sent from the microcontroller. So I will start off, before I do anything else, by making my life easier. Right, when a signal is sent from the microcontroller. So that's going to be our starting point. So I think it's always useful to look at where air can come into the circuit. Air can come into the circuit through here, currently going nowhere, through here, currently going nowhere, and through here, valve 2, and it's currently causing the cylinder to be in-stroked. This is our starting point, but we are now told something's going to happen. So when a signal is sent from the microcontroller, and this is here, this is going to say, well, this causes, it's a 3-2 valve, it's valve 1. Now, the circles are not necessary, I just like to do it to keep my numbers not confused. The 3-2 valve 1 to actuate, and change state, allowing a signal to be sent to the 5-2 valve 2. So what we're saying is microcontroller comes on, and we're now able to use the top box, the on state of our 3-2 valve. So air's coming through, and you imagine that box is lined up down here, and air's coming through. And so that's sending pilot air to valve 2. You see this pilot air actuates valve. Terrible, I'll try it. Handwriting's not been great through all this, but some things need to be a bit clearer. This actuates valve 2, causing it to change state. And again, this means, looking at a diagram, we're shifting, sliding the box across. That means that air is now able to flow in this side, which will connect up this part over here, and it's going to cause the cylinder to outstroke. That's what's going to happen here. So let's describe what happens next with that as well. So we can say something like this allows air to be supplied to the left hand side of the cylinder, causing piston to outstroke. So that's what we've got happening here. So that valve 2 will switch across, and the piston is going to outstroke. But that isn't the end of the story, because the piston is going to do something else once it gets across to valve 3. Maybe you can see the actuator that we have at the top of valve 3. So the piston is going to come across, and it's going to interact with that. And this is just what we simply call a roller. and we'd say as the piston outstrokes it will actuate the roller on valve 3, causing valve 3 to change state. So what happens is our piston comes out like this, and it's going to click with that roller, and that will allow valve 3 to change state. And this will be kind of the end point. When valve 3 changes state, it allows a signal, air can flow through, and a signal can be sent through component 4, which is our unique vector resistor, and it can fill the reservoir as well. So it's going to be sent to the time delay components, and after the time delay, it will then send the signal through back to valve 2, and it's going to cause our piston to in-stroke again. But let's break this down one step at a time. So we've changed the state of valve 3. This allows a signal to be, rewrite that. This allows a signal to be sent to the time delay components. So collectively, component 4 and the reservoir are the time delay components. And after that delay, the signal will be sent to actuate valve 2, and then we've already explained how valve 2 works. There's a valve 2 changes state, causing the piston to in-stroke. So what happens at the end is the signal comes in here, and then we switch the valve over, so air is no longer coming in that side. We're back in our original position, so air can flow in here, and it will come in this way, and the piston will in-stroke again, taking us back to our starting point. So we could add, even say, due to air supplied to right hand side, so there you have it. We have described the circuit. When the signal is sent, it's going to allow valve 2, allow air through valve 1 to shift valve 2 over. That will outstroke our cylinder. As cylinder outstroked, it's going to itself actuate valve 3 via the roller, and that's going to send an air signal through component 4 and the reservoir, so it's going to slow down with the time delay there. After the time delay is up, it will supply a signal back to valve 2, causing it to flip back to its original state, and the air will be supplied to the right, and the cylinder will have air supplied to the right, and the piston will in-stroke again, returning to its starting point. So that describes what's happening in question 3.